See this question. Suppose if f of x and g of x are given to us, then we need to find area bounded between f inverse of x and g inverse of x. You can think about it. So what is the relation between any function and its inverse? What is the relation between any function and its inverse? The relation between any function and its inverse will be the graph of the inverse of a function will be the graph of its reflection of the given function about the line y is equal to x. If you consider the line y is equal to x, if you consider this is graph of the function y is equal to f of x, then how will be graph of y is equal to f inverse of x? It will be reflection of this graph about the line y is equal to x. This will be the graph of y is equal to f inverse of x. And let us consider one more. Let this be y is equal to g of x. Then how will be graph of this? It will be the reflection of this. The reflection of g of x about the line y equal to x, whose graph will be in this form. So the area bounded between the two graphs f of x and g of x will be same as the area bounded between y is equal to f inverse of x and y is equal to g inverse of x. So this area will be same as this area by symmetry. So this can be remembered as an important statement. Area bounded between f inverse of x and g inverse of x will be same as area bounded between the two curves f of x and g of x. See the next question. If 8 participants P1, P2, P3 so on up to P8 participate in a knockout tournament such that Pi will win against Pj if I less than j. That means P1 will win against all the remaining participants. P2 will win against P3 to P8. Same, continue till P7. Now then find the probability that P4 will reach final. So in what way P4 can reach final? That means first out of 8 players, what will happen? Quarterfinals will happen and then semifinals will happen. In both these quarterfinals and semifinals, P4 should win so that he can reach final. So in quarterfinals for P4 to win, so P4 should play against whom? Anyone out of the remaining P5 to P8. So if you name the players as P1, P2, P3, P4, P5, P6, P7, P8. For P4 to reach final, P4 should play quarterfinals with any one of these 4. So it will be 4C1 times. Suppose if P4 is playing with P5, he has to win in semis as well. So one person out of these 3 should also reach semifinal. So for that, one out of these pair should also play quarterfinals. So out of the remaining 3, choose any 2 which will form a pair. So if P4 and P5 will play, P4 will win. After that P6, P7 plays, P6 will win. Now remaining 4, we can form them into pair. Into forming pairs of 4 people into 2 groups. 4 factorial upon 2 factorial, 2 factorial. Both the groups have same number. So once again multiply by 2 factorial. This is for quarterfinals so that P4 will win and 1 out of the remaining 4 will win. Next, in semifinals who will reach? P1 will reach P4, 1 out of these 2. Let us say for example P2 will win or P3 depending on who plays against whom, and one more possibility is out of these 2 1 will win. Now we have to play semis in such a way that these 2 should form one team and these 2 should form one team, right? So if you want to find probability for this, so the total probability is, this can be done only in one way so that P4 can win. These 2 should play one semis, these 2 should play one semis so that one from each will win so that P4 can reach final. So what will be the total probability? For quarterfinals it can be done in 4C1, 3C2 and dividing these remaining 4 into 2 groups of 2 each, and semis can be played only in one way upon. Total, we can divide this 8 into initially quarterfinals can be played in how many ways? 8 factorial upon 2 fact whole power 4 into 4 factorial times semifinals can be played in 4 teams divided into 2 each. upon 2 factorial whole square into 2 factorial. So this is the ideal way of solving, but this is little lengthy to solve and there is more chance of doing mistake in the calculation part. Let us say alternative method, how to solve this. So what we will do is that divide them into two groups, group A and B, two groups A and B. So for P4 to reach final, one will reach final from the group A, one will reach final from group B. So for P4 to reach final, the remaining 3 people should be out of the remaining 4 so that P4 will win all the games. So out of the remaining 4, out of P5, P6, P7 and P8, choose any 3 out of the remaining 4, 4C3. Now the remaining 4 players will form here P1, P2, P3 and P8 for example, right? So number of favorable cases will only be 4C3 upon. From here P4 will definitely reach final and from this group P1 will reach final, right? Any 3 out of the remaining 4 you can select so that P4 can reach final. So 4C3 times selecting 1 out of 3 out of the 4 upon dividing this 8 into 2 groups of 4 each will become 8 factorial upon 4 factorial whole square divided by 2 factorial. So if simplify, both of them will give us the same answer, but this will be a more easy and convenient way to solve this question. This way is little complicated, this is the more easy way.